All right, so we are moving right along to Module 10 on Monday. Sorry I was absent. Hopefully you got the message before you came up here. I did email in advance. Um, Hopefully you caught the video for Module 9. We're moving into Module 10. Today will be just a one-day module again. We will have a few of these because if you pay attention to the number of modules in the class, we have 18. We only have 16 weeks to do it. So that means we got to do a couple of modules that are shorter than 1 week. And this is one of them. The reason for that is that it's relatively straightforward, but it's sort of one of those things where we're going to level up our skills just a little bit in terms of what we can do with Python. We're going to talk about Python modules today. Python modules are one of the things that makes Python really cool because you can expand the language and add virtually any capabilities to the language that you want. In fact, Python modules can be written in any language. They don't even need to be written in Python to be usable in Python. So it's pretty cool and allows you to do almost anything you can imagine with Python once you have that capability. So today I'm going to show you how modules kind of work. We've used a few modules, but I'm going to go a little deeper into how they work and why and that sort of thing. I'm going to show you how to install Python modules into your PyCharm installation, and then I'm going to show you how to create a custom module. We'll get into A10, which is using the idea of custom modules to take the rock, paper, scissors application and break it apart into a modular app. So that's kind of the roadmap for today. And we'll start with the basics of modules, right? So we've been using random quite a bit, right? So we import random, and then if we wanted to print a random integer, we'd say random print random dot randint, and then we'd feed it a couple of parameters that specify the lower limit and the upper limit. So we know when we run this code, we're going to get a random integer printed out between 1 and 10. So that's how that works. So what I'm saying here is I'm actually importing a whole module here. It's not just randint, it's a module that has a ton of different different things in it, different functions, data points, capabilities related to the generation of random numbers or random items. So if I wanted to, there's another way I could do this. Instead of just using import, I could say from random. So if I'm using the keyword from random, import randint. What that means is from the random module, I'm importing just that one function, nothing else. And when I do that, I no longer have to use the dot notation down here. I can just use that command. If I wanted to import multiple things from random, I could put a comma here and I could list other functions if I wanted to as a comma separated list. The upside to this is that you're not importing a huge module just to do one quick thing. You don't have to use dot notation, which saves you a few keystrokes. For larger modules, you might save a little bit of RAM. You might save a little bit of speed. Most of the time, you're probably not going to notice, especially in this class. You won't notice at all with the programs we're writing. If you're writing something that was a large magnitude where you're using a lot of different modules and things like that, then you start to care about those things. You don't really care about that. One thing you do maybe care about, though, is that without the dot notation, without saying random dot randint, you have a higher frequency of functions that are named the same colliding with one another. So if I have something else in my program, my main program called randint, then it will collide with that if I'm just using this notation. If I'm using random dot randint, then it won't. So that's another thing that people say. Typically, when it comes to how to import things, how to import modules, most people say, and the consensus seems to be this online as well, that you should always just use import and import the whole module and use dot notation in your code rather than import things from modules as singular objects, unless you have the memory or the speed issues with your program, and then you can consider that very carefully. So this is how we use a module, okay, in a couple of different ways. If I want to install a module, I will go to this Python packages link right down here at the bottom of the screen where it says Python packages, okay? And if I wanted to, let's say I want to import or install something called emoji. Now I'm going to if I uninstall this really quick. Oh, I don't know if I can. Sorry, what? Okay, so if I go down to the very bottom of the screen down here where it says Python packages, that's where that is. Okay, and let's just say I want to install this one here. It's called Emoji 2. I already installed the regular emoji, but I want you to see what it looks like if it's not installed yet. So if I select something from a list, if I'm looking for a specific package, I select it from the list, and then I come over here to the very right-hand side of the screen, I click Install. Once that's installed, I can then use that just like I would any other package. You don't have to do that with every package. As you've noticed, we've been able to call packages like random or sys or time. We've used a few other packages throughout the class without really getting into how they're used. Some of those are included with Python. Things like emoji are not, but now that I've installed emoji, if I wanted to try it out, I would just import emoji, and with the emoji, I'm going to use the emoji.emojize command, and that takes a string, and it looks for anything that's in between two colons like this, and it will convert that name if that name matches the name of an emoji. Oops, especially if I don't run somebody else's code. There we go. Then it will print that emoji for you, which opens up all kinds of fun things that you can do. Now, in this Python packages section here, one of the things that I really like about how PyCharm does this is once it's installed, you're going to get this window over here that gives you examples of how to use each thing, and it tells you everything you need to know about how to use that command. Okay, and there's even a link here that tells you all of the emoji names so that you can do those. So it's a very useful resource when you're looking at how to use modules. By the way, this is an extensive and massively updated list. So you can find all kinds of things in here that are very interesting, and they will be documented as well. Yeah, it doesn't come with a whole bunch installed. It'll allow you to install them. Yeah, it'll allow you to install them in PyCharm. And then once you're installed, then you have that as an option. Of course, these computers, not your personal computer, but the computers in this lab, will reset each time you leave the class. So you'll have to reinstall those packages each time you sit down at the computer if you're using them, just to FYI. So if I was going to create my own package or my own module, it's not too hard. Let's say I have a file called custommodule.py. Okay, so the name of this file is this, custommodule.py. Let's say I want to create a really simple function that just says hi. So I'm going to define a function in my custom module that just says hello. Okay? If I save that file, and then in the same directory I have another Python file, I can now import that file name. So this, whatever I name the file, becomes the name of the module. So now if I want to execute that code, the say hi function of the custom module, I'm just going to go custom module, and notice it's already added to my autocomplete list. So that's really handy. The function that I literally just created in that other file, it's already pulled it in and has it listed for me. And so now when I run this, it executes that function as if it was in this code, but it's over here. Well, it's a way to separate your functions into another file, is what it is. And the reason that you might want to develop a custom set of functions like this, the most common reasons are if you're going to reuse the code for yourself, like if you're writing a bunch of functions and then you're going to reuse them with different programs, you might do that. Or if you're going to share your code with other people, this is a great way to do that. So if you're writing a program and you're in that program, you're writing functions that you aren't going to use anywhere else, you're not going to share this with other people, it's just for you, there's no real reason to separate them into a different module. There's no reason that I can think of anyway to do that, unless you just wanted your main program to be really small. It's not just functions though, we can also have variables. Like this string. And when I come over here, if I've imported that module, I can print out that message, custom module.str message, and it is accessible as if it was a variable in my program. Now, thing to remember is you can't change that variable because it's somewhere else. It lives in a different file. It's a read only. But if you have a database or something that you wanted to start out with, that's a viable way of creating a variable that's accessible from somewhere else. Okay, and I can, just like before, I can use the from keyword. And then that function works like I just defined it in that module. Correct. Just the function, not the string. And if I wanted both, I can put a comma here and I could import them both. But that's no different than just saying import custom module at that point, because I got everything. Yeah. So for A10, it's not super complicated, but if you didn't write your functions well for the rock paper scissors assignment, you're gonna end up going back and rethinking some of those functions. Let me show you what I mean. So for A10, what we're doing is we're taking the code that we wrote for rock paper scissors and we're modularizing it, meaning we're taking the functions out of this. And if we wrote those functions correctly, we should have at least like 3 or 4 functions to do that well. Okay, so here we've got functions here. And then I've got my main program loop down toward the bottom. Actually, this isn't mine. Where's that? A6. There it is. This is mine. That was somebody else's. Okay, so I've got my functions, got my variables, got my import random. So I've got to figure out what goes where. That's the trick here. And in doing that, I'm going to learn about how to set up custom modules and use those custom modules. So I know that I want these functions to go into custom module, right? Right away, it's telling me I've got some errors. Okay, these errors are, first, I'm using the random module here, and I haven't imported it here. If I want to use it in this, even though I'm importing this into a script that uses the random module, I still have to import it here. Because when this runs, it's going to look and say, did you import that first? So I need to import random to make this a viable script. Okay, so that takes care of that error. The other one's a little more complicated. If I look at report score, this is referencing variables that don't exist in this script. So I can't do it this way anymore because this is basically looking at variables that were global in scope to the program, and this can't automatically reach into the program where you're importing it and fix that. So the way I'm going to handle this is I'm going to make this function better. Now, what have I been saying all along about functions and globals? What do we want to avoid doing whenever possible? We want to avoid using global variables, right? Instead of global variables, there's a different way that I can handle this, because all this is doing is taking these scores and printing them in a user-friendly kind of way. So the easiest way to do this is to pass these two as parameters or as arguments to that function. So what I'm going to do is I'm going to go int c score. I'm going to call it a little bit something different than my main variables, just to not confuse myself. Int p score. And then if I just make those variables match that, now it's all clean. I'm just going to have to change the way I call that function just a little tiny bit in my main program, but this works now. So I've got all these functions are now really good functions because they work as a black box. I call the function. In this case, it doesn't have any arguments. And then I know that it returns rock, paper, or scissors. Okay? So who won works the same way. It has parameters, and then it returns rock, paper, or scissors. Or actually, it returns whether a P for player one or a C for the computer one. Okay? So these are all very clean functions that I can just use now. So I can just zip this little file up into a very small space and save it. And now this is what's left. I no longer need import random because it's not being used here. So I'm going to copy that over into my new program. And now I need to look at my main program loop, which is relatively small here. First thing I want to do, of course, is import my custom module. And then I just need to change. Now I could say from custom module import who won player hand, computer hand. I'm not going to do it that way because I want to use dot notation and make sure that I'm covering all my bases here. So I'm going to import the whole module. And I'm going to use dot notation. What you'll see is when I go custom module dot, look, it's listing the things for me. It's telling me that those functions are there. I made my connection the way I wanted it to. That's nice. So now I can copy and paste that because I know it's just going to work. So I got custom module.playerHand, custom module.computerHand. Now custom module.reportScore needs these two scores passed to it as parameters now. It's not that much harder, but it is something I need to do. Int comp score, int player score. So now I'm sending those parameters. And that's it. No more errors. Let's see if it works. Okay, so rock, paper, scissors. I'm just going to choose rock forever and ever. Sometimes these battles can go a really long time. In this case, the computer won. So there we go. Process finished. Exit code 0. It all worked just the way it was supposed to. And that is with my main program loop being this size here. How did I hide what? Oh, when I did this? Yeah. There's a little plus and minus sign. Anytime you have a block of code, you'll see right over here there's a little symbol that's a plus or minus. So if I want to collapse all of that and kind of hide all the extra lines, I just click that little module. And if I put my mouse over this, it'll show me what's inside. Okay, so, and then the custom module, same thing. There's all my functions that I wrote in the other file. Now, both of these files, both custom module.py and a10example.py, are in the same directory. They're in the same folder. That's why I can do it so easily. There are other places you could put custom modules where Python will find them. Easiest by far is just to put them in that same directory. Now, there's a process by which you can formally create a package that you can install using the package manager. And that I'm not going to go that deep because most of us won't even use that probably. But if you want to look into that, PyCharm will take care of that for you, and it makes it pretty easy. So especially if you've written your functions properly, that's totally key. Writing your functions properly is important. Okay, so we want to make sure we're doing that. So that is literally it. I've taken my rock, paper, scissors code, the whole program, and completed assignment 10 using my rock, paper, scissors right in front of you. It didn't take very long, right? The problem is going to happen, or the place where you're going to have difficulties is if you wrote your functions in a way where they can't act like black boxes with the input and the output, if they're not self-contained, if you're relying heavily on globals, you're going to have a bigger problem. You have to rewrite some of that stuff so that you're passing in those as arguments and getting return values. So this is really, it's sort of a head fake, right? I'm pretending to teach you about modules, but really what we're doing is beefing up our functions. If you have great functions, modules are a piece of cake. If not, they get a little trickier. So in working through this with your rock, paper, scissors assignment, you're not writing a whole lot of new code. You're just sort of going back and looking at your code from a new angle that'll make it a little bit stronger, more robust. Any questions? All right, cool. Plenty of work time. So